Welcome everyone to today's presentation on our thermal interface material. We're excited to announce our new high-performance thermals as well. My name is Luis Bonet. I am one of the non-metal application engineers here at LeaderTech. I want to let you know if there are slides that I go through too quickly for you, or you would like to print any of these out. We are including the PDF version of the presentation for you so you can look through the charts and graph as you like following this presentation. The overview. Part 1. What is thermal interface material? Part 2. Traditional TIM materials. Part 3. New high conductivity TIM material. These are carbon fiber, graphene, and indium. Part 4. Where are they used? Part 5. Property comparisons. What is a thermal interface material? Thermal interface material, also known as TIM, are a heat transfer media which conform to surface gaps and mating surface irregularities to fill the air gaps and conduct heat from a heat source to another surface or heat sink. Macroscopic planar misalignment. Mating surfaces do not align well due to planar misalignment, but with the power of magnification, we can see that in reality these surfaces have a roughness not visible to the naked eye. The contact will occur at the high points of each. The low points are just pockets of void filled with air. Enter thermal interface materials. They eliminate air gaps and increase the heat transfer between two mating surfaces. They conform to uneven microscopic mating surfaces, allowing heat to flow from one surface to the other in order to reduce the overall temperature of the device in which the gap is applied. What is the design principle of heat dissipation? Thermal dissipation refers to a form of heat transfer. Heat transfer in this respect occurs from an object that is hotter to surrounding objects and environments that are cooler. Solution 1 consists of a heat spreader between two thermal interface materials. Solution 2 utilizes a single thermal interface material between the heat source and the heat sink, eliminating the amount of components required in the application. Here is an example of Solution 2. Computer processors generate a lot of heat when operating. A thermal interface material is used between a computer processor and its heatsink to allow the heat to flow out of the processor. LeaderTech's traditional thermal products include thermal gap fillers, pads or sheets, thermally conductive electrical insulators, thermally conductive graphite, thermal grease or gel, and thermal double-sided adhesives, which we will discuss each of them up next. Our traditional product offerings have various features, applications, advantages, and disadvantages. Based on your design features, you can pick and choose whichever thermal product is best applied for your project. Here is our selection of our silicon-based thermal gap fillers or TGF. Their thermal conductivity ranges from 1 to 8 watt over meter Kelvin. Available in soft material with a hardness of 10 short C, silicone-free acrylic that reduces material outgassing, boron nitride that provides electrical insulation, fiberglass carriers with low tack, allowing material reusing for prototyping purposes. These are also available with adhesive, but this is discouraged since it reduces the material conductivity from 15 to 30%. Thermally conductive insulators or TEI-10 series are silica gel-based materials that provide both great electrical insulation and thermal conductivity simultaneously. Thermally conductive graphite or TGR10 material is made out of natural graphite, which provides high thermal conductivity of up to 400 watts per meter Kelvin for the horizontal direction. Thermal grease or TGZ material is available with thermal conductivities from 3 and 5 watts per meter Kelvin. It is a highly conformable pre-cure grease with low mechanical stress, able to fill the smallest of gaps. Thermally conductive double-sided adhesive, or TCTO6, are highly conformable thermal interface tape, able to bond surfaces and eliminate the need of potential mechanical fasteners in the design. Here's a real-life case of a modern device with thermal issues. In May of 2022, Tesla recalled close to 130,000 vehicles due to CPU overheating, causing important operations to lag or restart. When the vehicle CPU restarts, it increases the risk of transit accidents. So those were LeaderTech's traditional thermal solutions. Up next, we are going to present our new high thermal conductivity materials. The new high thermal conductivity materials are divided as carbon fiber, or TCF, graphene, or TGN, and indium, or TCI. We introduce four different types of TCF materials divided in two groups: regular carbon fiber thermal pads, TCF 160, TCF 200, and TCF 250 with thermal conductivities of 16, 20, and 25 watt per meter Kelvin respectively, and ultra-thin carbon thermal pad, TCF 350, with a thermal conductivity of 35 watt per meter Kelvin. Carbon fiber thermal pads provide a higher thermal conductivity than our traditional thermal gap fillers. Its lightweight and high strength contribute to the overall strength and durability of the material without adding excessive weight to the application. The TCF material applications are base stations, graphic processors, microprocessors, telecommunications devices, and cell phones. Its features and benefits are that it provides a high thermal conductivity, good compression ratio, is RoHS and REACH compliant, and halogen free. TCF material has seen a lot of use in the telecommunications industry. Due to its thickness and high thermal conductivity, TCF materials are an excellent application for newer smartphones and tablet devices. Because of their specific design, Samsung has been one of the main users of carbon fiber thermal products in recent years, particularly the Samsung S8 and Samsung Galaxy Note 9. The Samsung S8 uses a Solution 2 configuration of a single carbon fiber sheet, and the Samsung Galaxy Note 9 uses a Solution 1 configuration of two thermal sheets, graphite and carbon fiber, between a heat spreader, a copper foil sheet. As mentioned previously, TCF material applications range from 5G base stations, aerospace and radar systems, and electric vehicles. Our second new high-performance thermal material is graphene thermal pads, or TGN 700, TGN 900, and TGN 1300, with thermal conductivities of 70, 90, and 130 watts per meter Kelvin respectively. Its high thermal conductivity makes it one of its most celebrated features. It can efficiently transfer heat at rates surpassing those of traditional materials like copper and aluminum. Its minimal thickness allows for the creation of ultra-thin and lightweight thermal management solutions that are crucial in modern electronics. TGN material applications are 5G base stations, graphic processors, microprocessors or CPUs, and data processing centers. Its features and benefits are very low thermal impedance, high compressibility, high resilience, low density, and excellent thermal stability. Here is a visual comparison of each thermal product under compression. You can see how the graphene material barely deforms or expands under compression as opposed to its counterparts. Our final high-performance material is called Indium Thermal Pad, or TCI 800. Boasting a thermal conductivity of 80 watts per meter Kelvin and very low thickness, Indium can conform to regular surfaces, providing excellent thermal interface material components. Its main feature is its ability to soften at around 80 degrees Celsius, effectively filling microscopic gaps and providing an unbroken path for heat transfer. The TCI material applications are CPUs and APUs, video game consoles, virtual reality devices, and server products. Its features and benefits are very low in thermal impedance, works under low pressure, excellent thermal stability, and replaces liquid metal as a thermal interface material. The benefits of indium over liquid metal are liquid metal is a viscous material, it can damage components inside the application, and finally, components may be required when liquid metals is used. Iron Man suit is a good example of the application of thermal interface products. The brain or the CPU and GPU, memory devices designed for the storage of data, and energy supply, DC and DC converters, LDO regulators, and PMU or phasor measurement units. This is a properties comparison of our thermal interface materials, ranging from the traditional thermal pads, the TCF, the TGN, and the TCI materials previously discussed. That will be the end of our presentation. We love to hear your questions. Feel free to contact us at sales@leadertechinc.com or call us at 866-832-4364. Thank you.